Hello, dear students, and we came back again to study another part of chapter 3 that I think we reach in this topic. Bernoulli's equation. What's Bernoulli's equation and how we can to solve example actually. Bernoulli's equation, we have this state of Bernoulli equation said that the pressure in a fluid decrease as the velocity increase. So we know that the relationship between pressure and velocity inversely proportional. If one of them is going to be increased, the other is going to be decreased. This is the relationship between pressure, and this is the state of Bernoulli principle. So now we have some state to solve example. We have this rule. We have some rules I'm going to write in here for you. For example, the first rule that to solve exercise, we know the first rule. First rule, if the question said if the tank is open, we have, for example, the tank has two sides. This is the top side, and this is the bottom side. This is the bottom side. But if the question said if the tank is open, the tank is open to a top. For example, if this top tanks will be open, then we have to use this rule. We are going to be use this rule V1, which is equal to 2G H2 minus H1. So all of them is inside the square root. So this is the rule to find the velocity or find the height. Actually, both of them. This is the relationship between velocity and height. We can use this rule when the question said if the top of the tank is open. So immediately use this rule. In that case, the second velocity, which is equal to 0, the second velocity is 0, so we are going to find the first velocity, and even though the pressure number 1, which is equal to pressure number 2. So this is the first property. You should actually know those all property to solve the example. If the question said the tank is open, the tank stop open, immediately directly use this rule. The first velocity, which is equal to 2G bracket H2 minus H1 inside the square root, and the second velocity is 0, and both of the pressures are equal. This is the first case that in here we have. The second, we have another case. This is the first case. Second case, if the pipe is horizontal, if the shape of the pipe like that is horizontal, if the pipe is horizontal, the first height equal to the second height, then we are going to be using this rule, P1 plus 1 over 2 rho V rho V 1 square equal to P2 plus 1 over 2 rho V2 square. Rho V2 square. So we are going to be using this rule when the question said if the pipe is horizontal, both of the heights equal, we are going to use this rule. P1 is the first pressure, and 1 over 2, this is density and this is volume. This is the second pressure, density and volume. Okay. We have another note that's left important. Or let me write down in here for you. Okay. Second, or another note that's left. Then we are going to be solving example. If the question said to find the speed of fluid that leave the spigot, to find the speed, how we can find the speed? Actually, now I told you to find the speed we are going to be use which rule? This rule, 2g bracket v2 minus v1, all of them inside square root. The first velocity, 2g h2 minus h1 inside the square root. This rule is correct when the question said find the speed or velocity of fluid that leave the spigot. Use this relationship. Good. This is the same thing, huh? Now I said the P is pressure, 1 over 2 is kinetic energy per unit volume, plus gravitational G, H, and that's it, all of them. Bernoulli's equations rule. Okay, look, be with me now. The question said a water tank has spigot near its bottom if the top of the tank is open. Please highlight this for me. Now I told you if the question said if the top of the tank is open, immediately you should think about this. I told you if the top of the tank is open, immediately the second velocity equal to 0. Okay. Determine the speed. Which speed, mister? Actually, the first speed. You know why? Because you have to find the first speed. Because the second speed is 0. Of course, you have to find the first one. Which the water leave the spigot when the water level, and this is height, h, above the spigot. So, find first speed. Easy. I told you the rule. v1, which is equal to inside the square root, 2g h2 minus h1. We said if the questions, you should read the questions well. The question said the top of the tank is open. Immediately you should know the second velocity, the second speed is 0, and the question said determine the speed. So because the second speed is 0, so suddenly you have to understand you have to find the first speed in here. Because the second is 0, of course the first is left, so I have to find the first speed. Good. We know you have to use this rule immediately. So 2 times 9.81 times so students, instead of writing h2 minus h1 immediately, this answer 0.5 or 0.500, this is the 0.500. Like instead of h2 minus h1, suddenly immediately write 0.500, 0.500, because only we have this height. Only we have this height. So h2 minus h1, both of them is 0.500. So you can times all of them and take square root. So the velocity, which is equal to 3.13 meter per second. I gave you the note because the question said tank is open, so immediately use this rule. Okay. The first question, again, another question. Good. A large storage tank, open to the atmosphere at the top. Again, we have what? Open to the atmosphere top. We say at the top of the tank is open. Again, you should understand which rule you are going to be using. And filled with the water, develop a small pool inside. And this is the height, 60 meters. This is the height. And if the rate of the flow water equal to this number, determine the following. The part A, find what? The speed which the water leaves the hole. Find the speed immediately, Papa. Look, I told you what in here, because in here the question said the tank is open. Again, the second velocity, which is equal to 0. So because the question said find the speed, the question means find the first speed. So the first speed, rule v1, which is equal to 2g h2 minus h1, and all of them inside the square root. All of them inside the square root. Yeah, same, easy. And 2 times 9.81 times the value, as I told you, like the previous question, h2 minus h1, both of them, the answer is 16 meter. So 16. So times both of them and take square root. So the first speed, which is equal to 80 meter per second. So this is the answer of part A. Okay. The second one, find the diameter. It means find D of the hole. Find the diameter. Student, I think I told you we have a rule. One of the rules that we have in here, the relationship between velocity, the fluid speed, and the area. If you remember the previous video, I think we have explained it. A1 equal to V1 and A2 equal to V2 equal to V2. This is the relationship between the area and the speed. So now, because the question says find the diameter of the hole, to find the diameter of the hole, we will be using one of them. Let me make a space. Good. But now in here you have to write flow rate. Flow rate equal to A1 times V1. So we have the flow rate equation. This is the answer, the value of the flow rate equation. So 2.5 times 10 power negative 3 over 16. In this question, first go to find the area. Let me do it on this smart board to understand. Look, Baba. We have flow rate. Flow rate, which is equal to A1 times V1. We have the value of flow rate, which is equal to 2.5, which is equal to 2.5 times 10 power negative 3 over 16. So even though in here we go to find area number 1, but Mr. what about velocity number 1 or the speed number 1? The speed number 1 we found in the first part A, which is the answer. It was 18. The first part that we have found the value of the speed. The answer it was 18. So in here is mathematical equation only. Go to find the area. So this is 18A1. You can divide by calculating the answer. I don't know equal to what actually. In here, go to find A1. I don't have calculator actually to tell you the answer, but to find, you can divide this number by that one. You can divide both of the number, then arrange the equation. The answer of the area, of area number 1, which is equal to 2.3 times 10 power negative 6 meters square, because this is area, that's why the unit should be meters square. We found area, but the question said find diameter. Actually, this is area. How we can find diameter? Because the shape of the pipe, the pipe of the top is like a circle, so you have to go. We are going to be using the because as I told you, the pipe has two sides, the top side, the bottom side. The top side, on both of the side, the side of the tank, it's like a circle. So in here, you have to go to right and use the area of the circle. So the area of the circle, area which is equal to pi r squared. We found the area which is equal to 2.3 times 10 power negative 6, and we have the pi value 3.14 times r squared. Go to find the value of r, divide both by 3.14 and divide this by 3.14. The 3.14, 3.4 going to be cancelled. Divide this number, and then because in here we have r squared, take the square root, and the last answer r, it's radius. Actually, don't do this mistake. R, this is radius, not diameter. The value of r, which is equal to 7.3 times 10 power negative 4 meter. Students, this is r, but the question says find diameter. To change radius to diameter, we are going to times this number by 2. Only times it by 2. The answers will be times this number by 2. The answers will be diameter, which is equal to 1.5 times 10 power negative 3 meter. So first of all, use this rule and go find the value of area. When you find the value of area, this is the area which is equal to 2.3 times 10 power negative 6. Then we have to go use this rule, the rule of area, because as I told you, the top of the tank is like a circle. So we have to use this rule. We have area and we have pi. Find the r radius. We found the radius r. This is the answer, 7.3. Then this r, the question but said find diameter, times this number by 2. The answer that we get in here is 1.5 times 10 power negative 3, and this is diameter. Good. Done. Part B. Actually, the other questions all the same. You can do it by yourself actually. Now we are going to be solving some questions in section review 3.3. Good. In here we have a nice question in here, section 3.3. The question said the time required to fill a bucket with the water from a certain garden hose. This is the time t, because 30 seconds. If you cover a part of the hose nozzle with your thumb, so that's the speed of the water leaving the nozzle dubs. How long does it take to fill the bucket? Okay. In here we have actually the question said in here the time required to fill with the water takes 30 seconds. If you cover part of the nozzle with your thumb, that is the speed of the water leaving the nozzle dubs. How long it takes? The time is still 30 seconds. Still it's 30 seconds. The reason is because the volumetric flow rate is constant. The volume of the nozzle or the volume of this pipe still is constant, so it takes same time actually. Now I only going to be solving this question and it will be done. Okay guys, so a water pressure in here that you have, the water pressure, this is P, flows through a horizontal pipe. Guys, look, we have in here horizontal pipe with the speed 1 meter second. The pipe is narrowed to 1/4 original diameter. Find the following. The first question said first in here we have the pressure P equal to 3 times 10 power 5 Pascal, and through a horizontal pipe with this speed. The first speed V1, which is equal to 1 meter per second. The pipe is narrow. It means the diameter. The diameter is 1/4 original diameter. 1/4, it means what, Baba? 1/4. 1/4, it means 1/4. So the diameter, the diameters in here, 1/4 is ordinal diameter. So in here we're going to write r equal to r1, or we can say r2, which is equal to 1/4 r1, because the pipe is narrow. In here the question said, just focus with me. The pipe is narrow. The pipe narrow to 1/4. This is 1/4 original diameter. Original diameter, it means R1. 1/4 original diameter. So if this is 1/4 original, of course this should be R2. Yani R2 equal to 1/4 R1. The question said find the flow speed. Find the flow speed, yani find the second speed, because you have the first speed which is equal to 1. And here the flow speed in the narrow section. So find now the second speed. If you remember the relationship between the area and velocity, speed, A1 V1, which is equal to A2 V2. How to find V2? Find V2, divide both sides by area number 2, area number 2. This area number 2 going to be cancelled. So in here, V2, which is left with this in here, area 1 V1 over area 2 equal. Because we have to know, because the shape of the pipe, we have, this is, for example, imagine this is the pipe. This is the pipe. This is the top of the pipe, and this is the bottom of the pipe. Look, both of the side, the shape is like a circle. So for both of them, this is the area number 1, and this is the area number 2. For both of them, you have to write down pi r square, because both of them shape like a circle. But in here, you have to name it actually, because this is the first area, and instead of the radius, write down R1, and this is the second area, and instead this R, write down R2, and that's it. Okay, so area number 1, we are going to write pi r square, but because this area number 1, write down R1 times the first velocity is 1, area number 2 again pi r square, but this is because this is the area number 2, and instead of radius, write down 2, radius number 2. So because both of the pi number are stable constant, both of them is going to be cancelled. So only R1 is left. R1. So write down the R1 again, R1 square, but instead of R2, because in here we have the relationship, R2 is equal to 1/4 R1. So instead R2, write down 1/4 R1, and because it's square, all of them inside the squares. Look what I did. And instead of R2, write down this R2 equal to 1/4 R1. So instead of R2, write down 1/4 R1, but because it's square, all of them square. So immediately this is easy. This R1 with this R1 going to be cancelled. So in the down in the up, only 1 is left. But in the down, 1/4 square. 1/4 square will be 1/16. Right? So you can flip with this. The last answer will be 16. So the velocity 16 meters per second. So this is the answer of part 1. Good. Students, so the part B you can solve by yourself. It takes our time, and all of them same and easy. Now we reach chapter 3, section reviewing. In here, same thing. I only explain some of them that's important. Look, I highlight for you. One of the question here that we have, question 2. The question said, will an ice cube float higher in water or in mercury. So we have this ice. This ice will float. For example, this is a mercury, and this is water. This ice will float in which one of them? In water or mercury? Actually, we studied this in chapter 3. It depends on the density. Which density in here? If we are comparing the density for both of them, which of the densities are greatest? Actually, the density of the mercury is greatest because the density of the water is 1 times 10 power 3 only, but the density of mercury is 13.6 times 10 power 3. So you can't compare, you can't see by your eyes. This is the density of water, 1 times 10 power 3, and this density of the mercury, 13.6 times 10 power 3. The density of the mercury is greater. So because the density of the mercury is greater than the density of the water, it means the ice can float on the mercury's liquid, not on water, because the density of the mercury is greater than the density of the water, so it can make the ice to float on the surface. Okay. So the answer, we can answer like that. First, question 2 answer. Ice cube will float. Write down ice cube will float higher in mercury. Higher in mercury. Because mercury's density greater than water density. Because the density of mercury greater than the density of water. Because the density of the mercury greater than the density of the water. Question 4. Question 4 in here that you have looked. Will a ship ride higher in islands, freshwater, over ocean? Baba, look, again, those type of questions actually you have to memorize or not memorize. The teacher going to give you the teachers, they will give you the density for both of the liquid. Then you can decide actually it will high in which of the type of liquid. Will a ship ride higher in islands, freshwater, or lake? In island, freshwater, lake, or ocean? But we have two type of liquid in here. Freshwater, the freshwater is liquid 1 times 10 power 3. Like the previous question, now same thing, it's freshwater every time 1 times 10 power 3. But the ocean's water 1.025 times 10 power 3. Which one is the greatest one? Of course, the ocean. Because the ocean is greater one, so the ship can ride in oceans comparing with the freshwater. Because the density of the ocean is greater. The answer ocean. The ship can ride in ocean's liquid comparing with the freshwater because in the ocean because the density of the sea of water, or we can say the ocean, which is greater than the density of fresh water. Because the density of the seawater or ocean greater than the density of the fresh water, the oceans, the ship can ride high in an ocean's water, not on fresh water. Then question 8, in here we have solve an example. Question 8. This example actually we solve it. That's okay, never mind, I'm going to solve it again for you. It's like a reviewing. An object weighs is 350 Newton in air. So we have, it means FG object in air, which is equal to 350 Newton. When immersed, this object it sinks, it goes in the water, immediately down in the waters. Then the weight is going to be changed, of course, because this is the first object in Earth 315. When the object is sink under the water, the object weight become 265. So in here you are going to be write Fg object in water, which is equal to 265 Newton. And when it immersed in oil, so you have now three types of liquid. When it immersed in oil, the weight become 269. Fg object in oil, 269 Newton. Find the following. First, the first question, part A. Find the density of the object. Find the density of the object. P object. Look at things that I wrote in here. We have 3 weight Fg object in air, 315 Newton. Fg object in water, 265 Newton. Fg object in oil, 269. So the first part question said find the object, the density of the object. Okay. If you remember that we have studied two rules. I'm going to write down both of the rules in here in front of you. The first rule, we had this rule, Fb buoyant force, which is equal to Fg object in air minus Fg object in water. Fg object in air minus Fg object in water. Then this is the first. Another rule that we also studied, Fg object in air over buoyant force, which is equal to density of the object over density of the water. So yeah, in here the question says find density of the object. Which one? It means this one. Rho O, it means density of the object. How we can find density of the object? Look, check with me. We have the Fg object in the air. We have in here the number which is equal to 350 Newton, and we have even the density of the water. We know all of them. It's 1 times 10 power 3. We can find density of the object, but you have a problem because in here we don't know the value of buoyant force, which is equal to what. So, but there's no problem, actually, no worry, because we can get the benefit from the first rule. We can use this rule to find the buoyant force. Yalla. Buoyant force, which is equal to Fg object in air. In here we have 315 minus Fg object in water. We have 265. You can minus both of them and you can get the answer of the value buoyant force. The value of buoyant force, which is equal to 50, will be 50 Newton. Finish, done. We found the buoyant force. So done, finish actually. So you can immediately use this rule to find the the density of this object. Fg object in here we have 315, and buoyant force in here we found in the previous rule, which is equal to 50 Newton, equal to, we need to find the density of the object and over the density of the water, and every time we know it's 1 times 10 power 3. Okay, so now we are going to be minus both of them. Density times 50 will be 50 density O equal 350 times 1 times 10 power 3 will be 350 times 10 power 3. Yalla, find the density of the object. Divide both sides by 50 by 50. So this 50 going to be cancelled. The density of the object, you can divide both of them. Whatever the answer equal to any of the numbers, the answer equal to 6.3 times 10 power 3 kilogram over meter cube. So this is the answer of part A. Good. Part B. Part B's question said find out the density of the oil. Find out the density of the oil. So in here we have to know that the type of the liquid in the part B, it's oil, not water. Don't do a mistake or don't mix it with the part A. Part B, find the density of the oil. First of all, write down the rule again. Fg object in air over buoyant force, which is equal to density of the object over density of the oil now, because part B of the question said find the density of the oil. Be careful. So instead of writing density of the water in here, we have to change it to density of the oil. Good. Find the density of the oil. We need to find this density of the oil. Yalla, again. Be careful with me, Baba. Look. Fg object in air, actually, this is the same number. Still it's 315. But buoyant force is going to be changed because in here we have oil. So again, you have to use to find the buoyant force in here. Buoyant force, which is equal to Fg object in air minus what? Fg object in fluid. But which type of fluid? Oil. Oil. Good. Fg object in air, again, it is same thing, 315, but minus by the object Fg object of the oil. What was the number, the value of Fg object in oil, which is equal to 269. 269. So minus both of them, you can subtract both of them, the answer 46. 46, this is the buoyant force when the medium or the type of the liquid in here is oil. So the buoyant force in here, we found the number which is equal to 46. And the density of the object. Mister, where's the density of the object? Students, there's no worry, because in the first part and the previous part, part A, already we found the density of the object. The number, it was 6.3. Look, 6.3 times 10 power. 6.3 times 10 power 3. We found the density of the object. So in here, this is the questions become so easy. You can go to find the density of the oil. Actually, I don't have calculator, but you can arrange the question. You can multiply this both of them, and this is both of them. So the density of the oil times 315 will be density oil and 315 equal to, multiply this both of them, will be 46 times 6.3 times 10 power 3. Then to find the density of the oil, divide both sides by 315 and 315. So this 315 going to be cancelled. You can divide all of them and you can get the answer easily. You can get the answer, you can get the value of density of the oil. Good. So this is about question 8. And here now we have question 10. Question 10 is a good question. In which case the pressure on the block is less? In which case that the pressure, we have less pressure when placed a single nail or multiple nails? Look, Baba, this question 10. The question said, in which of the case that we have less pressure? As you know that the relationship between pressure and area is inversely proportional according to this rule that even in the previous chapter we studied, pressure which is equal to force over area, and the relationship between pressure and area inversely proportional. One of them increase but the other decrease. So in which case the pressure on the block is less? So in here we have condition. يعني we need less pressure. So of course if the pressure become less, it means the area, it must be greatest area or higher area, because the relation between P area and inversely proportional. The question says, or the question said, in which case that we can get less pressure. In which case that we can get less pressure. We can get less pressure if you have a lot of area. So the answer, which one is the answer correct? Which one is the correct answer? Single nail or multiple nail? The answer, of course, multiple nail. We know why multiple nail. You know what is nail? This is nail, actually. For example, this is one nail, two nail, three nail, four. We have a lot of nails are next to each other. We have a series nail. We see that in here we have a lot of nails, and this a lot of nails, it takes a lot of area. Because it takes a lot of area, so because we have a lot of area, so of course we can get less pressure, because the relationship between pressure and area, as I told you, is inversely proportional. The question said, in which of the case that we can get less pressure? We can get less pressure when we have a lot of area. We have multiple nails. We have multiple nails. Look, but what if we have a single nail only? We have only this nail. This is small area, but it's a greatest area. So of course this is the correct one, because we have a greatest area. If you have a greatest area, we can get a less pressure. That was a good question, actually. Okay. Question 19. Let me solve question 19 about the pressure. Question 19. Question 19, the question said, submarine is at ocean depth. We have an ocean depth, so the depth h, this is h. Calculate the absolute pressure at this depth. We have studied what was absolute pressure. What was the rule, actually, if you remember? P, which is equal to P naught plus rho GH. Rho GH. So, calculates the absolute pressure. So, calculate the absolute pressure at this depth. Assume that the density of the water is this number and the atmospheric. So, you have all of them. Only apply the rule. Easy. This is the atmospheric pressure. Atmospheric pressure, in here we have, this is the atmospheric pressure number. Look. This atmospheric pressure number, which is equal to 1.01 times 10 power 5 plus, and this is the density. The density in here is given 1.025 times 10 power 3 times 9.81. This is the acceleration, and times the value of h itself. The value of h in here we have 250 meter. So only applying rule, easy. We have the atmospheric pressure and we have density G and H. You can times, and at the end, first of all, times this side, multiply, and the left side still do the same thing, multiply the right and left side. At the end, don't forget, so you have to plus the result. Good. Actually, chapter 3 finish all. I hope to understand the chapter 3, all of them, and you have solved an important question in chapter 3. Now we are going to be explain chapter 4, or leave it today. Enough. We solved some of the examples and some of the section chapter 3. For the next video, inshallah, we will start to explain chapter 4 and section 1 and 2 together, inshallah. Thank you for all of them, and have a nice day.